Hi, and welcome to Geeks for Geeks. I'm Siddharth Hazra. Currently, I'm an SD at Geeks for Geeks. Besides that, I'm also a candidate master at Code Forces. So, today we will be discussing a very interesting problem, that is Boolean matrix. So, let's talk about the feedback of this problem. This problem is a simulation based problem, and if you are new to 2D matrix 2D arrays, basically matrix is not a standalone something else. If you are given a 2D array, if you're new to 2D array, this problem is of medium level. If you're already acquainted with 2D array, this problem is an easy problem. Now let's talk about the problem statement. So basically here you are told that you are given a binary matrix. What is basically binary matrix? Binary matrix is nothing but a matrix which is only constituted by 0 or 1. Okay, so basically I can say that there is a human which can only respond yes or no, nothing else. So in the same manner, that robot is here as a binary matrix because a particular value can only be 0 or either 1 itself. Okay, same simple. Just whenever you see binary matrix, visualize a robot who replies in only yes or no. Okay, so what you basically need to do in this problem is, let's visualize if a particular element, let's say the addresses are 0001, 0, 0, 01, 11, 12, 20, 21, and 22. Let's say the value at this address is 1. Then you need to make all the values of row 1 as well as column 1, row is equals to 1 and column is equals to 1. Every value of row 1 and column 1, you need to make it as 1 itself. In the same manner, let's talk about this. If this given value is 1, then all the values on row 0 and all the value on column 2 would be made to 1 itself. Okay, so let's talk about the first test case, that is 1000. So here, what is the address of this? The address of this is 00. So all the values on row 0 and all the values on column 0 needs to be 1. So this is 10, this is 01, this is what? This is 11. So this is 0. Either the column should be 0 or row should be 0. So this would remain 1. This is, here row is 0. Yes, either of the condition. So row is equals to 0. We need to make it as 1. Here we can see column is equals to 1. So this would also become 1 because we have something here. And this is 1, 1. Neither the column is 0, neither the row is 0. So this would remain as 0. That is why the output to this is something like this. Let's see the very next one, and this would give out the solution. That is why, let's talk about the intuition of the problem. I would say that most of the easy till the easy medium, from school level till the easy medium problem, if you just have a notebook and you visualize the test cases that are given, you would be able to solve most of the problem by just general mathematics or simulation or easy based. Like if you have a little bit of backed up by DSA concepts, then this problem would be a cakewalk. If you have a pen and paper handy with you, you would be able to solve most of the problems. Let us see that. So given the first test case, it is 1, 0, 0. Then it is 1, 0, 0 again. Then it is 1, 0, 0 again. Then it is 0, 0, 0. Good enough. Let's write the addresses of that. 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, and 1, 2. 2, 0, 2, 1, and 2, 2, 3, 0, 3, 1, and 3, 2. So the rows we need to make 0 is 0, 1, 2. So here I would just write row that we need to make it as 1 would be nothing but row 0, row 1 because of this, and row 2. row 3 is not there. Okay, so anything else? Yes. So we need to also take care of column 0. Column 0 is only there, column 0 is only there, nothing else. So all the values of row 0 should be made as 1. Okay, so row 0, all the values 1. Row 1, all the values should become 1, 1, 1. Row 2, all the values should become 1, 1, 1. Then column 0 should become 1. So column 0, everyone is already there. We just need to make this as 1. So the output would be everyone is 1 except these two. Okay, that is why the output is like that. So what we can really see is we can first iterate over the values of 1. And when we see a value 1, we need to store the row and the column of it in two different arrays. Now, after we have iterated, we would have the list of rows and the columns that needs to be made as 1. So now when we would iterate, we would see if that column is existing in our so-called small pen, like so-called small hash list or not. If it is existing, we would make its value as 1. If not, we would make its value as 0. So two external arrays are needed. Basically, it is not external, that is termed as auxiliary data structures. Two auxiliary arrays of 1D, one for row, one for column, or you can use a 2D array of dimension 2. Okay, number of rows as 2 and the number of columns as the same thing, and that would solve the purpose. So here for simplicity, we would be taking two arrays of 1D, one for rows and one for columns individually, and then we would start putting it up there. Now let's move to the implementation. The intuition should be clear. Let's move to that part. So here we don't really need to return anything. We already have the given matrix. We just need to edit it and it is passed by reference. So we would just name it as mat for simplicity. Okay, mat for simplicity. Now we don't really have the number of rows and columns. So what we can do is we can simply go to the first row and find the size, because the size of each of the rows would be same. And we would go to the first column and find its size, because the size would be same. So we found the number of rows and the number of columns. This would be lowercase r and lowercase c itself. After that, we would define a row of size r and a column of size c. This is done. Now we would make every value as 0, like this doesn't be required as, like nothing is visited up till now. Okay, so for int I is equals to 0, I is less than equal to r and I plus plus, and then we would simply say that the row of I is equals to 0. After that, we would do the same thing for the number of columns. So we would say for this would be less than equal to c, and this would be something like col of I is equals to 0. Now let's start the iteration. Okay, so now we would iterate on the whole matrix. So for int I is equals to 0, I is less than row and I plus plus, then we would have the j. For int j is equals to 0, j is less than column and j plus plus. At this point, if that particular value of the matrix, that is row I and j, if this particular I and j is equals to 1, then we need to save it. Only we are concerned about that. So we would say go to that row I and go to the column j, make both of them as 1. Why? Because to remember, initially we make every value as 0. This just tells me that nothing needs to be changed. Now whenever we find a 1, we go to the respective index and we say this value needs to be changed, this column needs to be changed. That is why we are writing 1 at that point. So after we are done, we need to append it back, okay, to the origin. Now we need, first we had all the information from there. Now we need to put back the information and edit the final array itself. So now what we really need to do is, again, we need the traversal of the matrix. So I would just copy this for loop, and now I would say that if the particular row of I or the particular column of J is equals to 1, then we would say matrix of I dash J should also be equal to 1. And we have edited the given matrix itself. It was passed by reference, so we don't really need to return anything. Now let us see how many syntactical errors I'm doing, because the concept would remain the same. Okay, seems like I got an issue. Okay, so I need to have mat here. Okay, I need to have this again. So now compile and run again. Good enough. Let us submit this and see if we can get an AC or not. So, yes, we did it. The time complexity is we are iterating over each of the element twice. Why? One for seeing if that value is 0 or 1. One for making it 0 or 1. Okay. So, it would be 2 multiplied by n square m. What is n? Number of rows and number of columns. Ignoring the constants, it would be big O of row multiplied by column. Talking about the space complexity, it would be big O of row plus big O of column. That is R big O of R plus C. Okay. So a small optimization can be this way, that we can store all the information in the array itself in that particular arena of this particular first first column itself and the first row. We can save all that information and we can do it. That is a better optimization, but the desired optimization is done. But if asked in an interview, please remember this small concept. So that's it for today. This is me, Siddharth Hazra, signing off.